Good afternoon, everyone. Thank you for joining us. You can see it's dark behind me. I'm Steve,
And I'm Scott.
and together we are Backyard Musings pre-taping.
Yep, we pre-tape, and we are talking about some space rocks. So strap in. We're gonna tell you all about it. Or at least
Yes,
the people.
sir.
We're gonna tell you what the people told us all about it. So
A team led by ICE-CSIC, not the Immigration Custom Enforcement. This is something else.
Right.
ICE-CSIC examined meteorites from documented historical falls, as well as samples from NASA's Antarctic meteorite collection. I didn't know there were meteorites in Antarctica. I didn't know that. Much about the makeup of small asteroids is still uncertain, yet these objects are drawing growing attention for what they may contain. Scientists believe they could host useful metals, preserve materials left over from the early solar system, and offer chemical clues about the larger bodies from which they formed. The results were reported in the monthly notices of the Royal Astronomical Society on November 8th, 2025. Would you like to know more?
to explore this potential, a research team led by the Institute of Space Sciences, which is the ICE-CSIC, examined samples linked to a C-type asteroids, carbon-rich objects in the solar system that are thought to be the source of carbonaceous
Mm-hmm.
chondrites,
Chondrites.
chondrites. Okay, chondrites. These, these results strengthen the case that these asteroids could play an important role in future resource use. The study also shows how their composition can help scientists trace their origins while supporting the design of the upcoming missions and the development of technologies aimed at using space-based materials.
Carbonaceous chondrites reach Earth naturally, but they account for only about 5% of all meteorite falls. Many are extremely fragile and tend to break apart during their descent, which means they are often lost before they can be collected. As a result, recovered specimens are uncommon and are most frequently found in dry, stable environments such as the Sahara Desert or Antarctica.
Okay. Quote, the scientific interest in each of these meteorites is that they sample small, undifferentiated asteroids and provide valuable information on the chemical composition and evolutionary history of the bodies from which they originate. That is according to Joseph M. Trigo Rodriguez. That's a hyphen in between the Trigo and the Rodriguez. First author of the study and astrophysicist at the ICE-CSIC, affiliated to the Institute of Space Studies of Catalonia. Okay. Haven't talked about them.
Researchers at ICE-CSIC were responsible for selecting and characterizing the meteorite samples used in the study. These materials were then examined through mass spectrometry at the University of Castilla-La Mancha by Professor Jacinto Alonso Azcarate. This approach enabled the team to measure the chemical makeup of the 6 most common types of carbonaceous chondrites in detail, helping scientists better assess whether extracting resources from such asteroids could be practical in the future. Great, mining.
The Asteroids, Comets, and Meteorites Research Group at ICE-CSIC investigates the physiochemical properties of the materials that make up the surfaces of asteroids and comets, and has made numerous contributions in this field over the last decade. Quote, at ICE-CSIC and IEEC, we specialize in developing experiments to better understand the properties of these asteroids and how the physical processes that occur in space affect their nature and mineralogy. That's according to Trigo Rodriguez, who leads this group. So I think I'm pronouncing that right. Trigo? Is that Trigo?
Trigo, yep. Furthermore, for over a decade, he has been involved in selecting and requesting from NASA several carbonaceous chondrites analyzed in the study, as well as devising several experiments with them. Since the ICE-CSIC is the international repository for NASA's Antarctic meteorite collection, quote, the work now being published is the culmination of that team effort, he adds.
Quote again, studying and selecting these types of meteorites in our clean room using other analytical techniques is fascinating, particularly because of the diversity of minerals and chemical elements they contain. However, most asteroids have relatively small abundances of precious elements, and therefore, the objective of our study has been to understand to what extent their extraction would be viable, says Paul Gibol Thomas, ICE-CSIC pre-doctoral researcher. Okay.
Quote, although most small asteroids have surfaces covered in fragmented material called regolith, and it would facilitate the return of small amounts of samples, developing large-scale collection systems to achieve clear benefits is a very different matter. In many cases, it deserves to be explored because the search for resources in space be susceptible to minimizing the impact of mining activities on terrestrial ecosystems. Okay. Points out Jordi Ibanez Inza, Geosciences Barcelona, researcher and co-author of the study.
Given the diversity present in the main asteroid belt, it is crucial to define what types of resources could be found there. According to Trigo Rodriguez, quote, they are small and quite heterogeneous objects, heavily influenced by their evolutionary history, particularly collisions and close approaches to the sun. If we are looking for water, there are certain asteroids from which hydrated carbonaceous chondrites originate. Which conversely will have fewer metals in their native state. Let's not forget, of course, that after 4.56 or a little over 4.5 billion years ago, give or take a billion years, since their formation, each asteroid has a different composition as revealed by the study of chondritic meteorites. Okay.
One of the study's conclusions is that mining undifferentiated asteroids, the primordial remnants of the solar system's formation considered to be progenitor bodies of chondritic meteorites, is still far from viable. On the other hand, the study points to a type of pristine asteroid with olivine and spinal bands as a potential target for mining. A comprehensive chemical analysis of carbonaceous chondrites is essential to identify promising targets for space. What is a carbonaceous chondrite? I mean, they keep saying that word. I do not think it means what they think it means.
I don't know what a chondrite is. Carbonaceous, that's got to be something that's got carbon in it, I would think, right?
Yeah, like a shell thing, right? Like a seashell?
I don't know. Maybe, or just some kind of a rock or a stone or something. I don't know. So,
however, the team states that this effort must be accompanied by new sample return missions to verify the identity of the progenitor bodies.
Quote again, alongside the progress represented by sample return missions, companies capable of taking decisive steps in the technological development necessary to extract and collect these materials under low gravity conditions are truly needed. The processing of these materials and the waste generated will also have a significant impact that should be quantified and properly mitigated, adds Trigo Rodriguez. Mitigated.
Yes, so
okay.
They want you to find a corporation that's willing to invest in this for profit.
Give me money. Invest in your money.
Give me your money. The team is confident of very short-term progress, given that the use of in situ resources will be a key factor for future long-term missions to the moon and Mars, reducing dependence on resupply from Earth. In this regard, the authors point out that if water extraction were the goal, water-altered asteroids with a high concentration of water-bearing minerals should be selected.
Exploiting these resources under low gravity conditions requires the development of new extraction and processing techniques. Quote, it sounds like science fiction, but it also seemed like science fiction when the first sample return missions were planned were being planned 30 years ago, says Paul Gribble Tomas.
And and you always say, Scott, that something that an engineer is working on now on a Mars mission or something, they're not going to see the results because the results might take 30 years from now. Maybe their cousin or their nephew or niece is going to see that. You know what I'm saying?
Yep.
Yeah.
Yep. And that's, I guess that's just the drive that they got to have, right? They can't expect to have instant gratification. This is
Right.
stuff that's going to be taking a long time to do. So, yeah.
In an international context, several proposals have been put forward, such as capturing small asteroids that pass close to Earth and placing them in a circumlunar orbit for exploitation. Quote, for certain water-rich carbonaceous asteroids, extracting water for reuse seems more viable either as fuel or as a primary resource for exploring other worlds. This could also provide science with greater knowledge about certain bodies that could one day threaten our very existence. In the long term, we could even mine and shrink potentially hazardous asteroids so that they cease to be dangerous, Trigo Rodriguez explains. Okay.
We don't need danger.
No.
Yep.
Very
Yep.
interesting.
Yeah. Yep. I'm sure I butchered a bunch of words in that one. So, but anyway.
All right, folks. Thanks for joining us. We'll catch you in the morning.
Take care, everyone. We'll see you tomorrow. Thanks.